While the NiFi canvas is generally useful for comprehending how the configured data flow is laid out, this view is not really made to discern the status of the system, or you certainly cannot see all the events happening to a single flow file while making the journey through the data flow. In order to help the user to understand how the data flow itself is functioning, also in a very granular level, NiFi provides several built-in monitoring tools, which can be found in the global menu of the UI. This is firstly the NiFi summary page, then the NiFi counters dialog, the NiFi bullet-in board, and finally the extensive NiFi data provenance view. We will discuss and demonstrate each of them separately. Let's start with the summary page. This is basically a table comprised of information about each of the components on the canvas, split up in different tabs. The information provided in the table is the same information that is also provided for each component on the canvas. These are numeric statistics pertaining to the performance of a component over the past 5 minutes, including the current status. These 5-minute statistics is going to be reset when NiFi is restarted. Besides this latest information, it is also often useful to have a view of historical statistics as well. This information is available for each component in the status history dialog, presented in a graph with a timeline of the last 24 hours, which can also be changed in the NiFi configuration. The graph also allows you to view only a selected time range within the last 24 hours, in a more detailed manner. The NiFi summary page further provides a link leading to the system diagnostics window, giving you information about how the system is performing with respect to system resource utilization, such as CPU, disks, and Java-specific metrics. Let's go ahead with NiFi counters. Counters are basically just values that can increase or decrease of a given delta. This is useful if you want to monitor and track particular values along your data flow. For this, it provides a way for a processor to track how many times some event occurred, such as counting the processed flow files or records. At the moment, there exists some processor using counters out of the box or allowing you to configure them. Otherwise, you could also simply achieve it with the execute script processor and a piece of Groovy code. And since those counters are held in memory, they are going to be reset by restarting NiFi as well. Let's look into the next native monitoring feature, the bullet-ins or the bullet-in board. The bullet-in board in the global menu shows by default a list of the latest errors or warnings getting generated by NiFi processors in real time. The same information what you can see when you navigate to the actual processor. In the settings tab of a processor, you can further change the logging level at which bullet-ins will occur for this specific processor, ranging from retrieving all the processor's information by configuring debug to no bullet-ins at all by using the option none. Those occurring bullet-ins are quite useful, but since you're not always watching the NiFi UI, you have also pre-built reporting tasks retrieving this bullet-in information, which you could then send via email, for example. Then, let's cover the last and probably most sophisticated inbuilt monitoring feature provided by Apache NiFi, the data provenance. While monitoring a data flow, you often also need a way to determine what happens to a particular flow file. NiFi's data provenance page provides that information. As we already know from previous modules, Apache NiFi natively logs and stores every information about the events occur on the ingested data in the flow. The data provenance repository stores this information and allows you to perform searches, conduct troubleshooting, and evaluate things like data flow compliance and optimizations in real time. In order to track and trace any data changes or to make adjustments to the data flow, you have also the possibility of replaying a data provenance event at a certain point in the data flow. And last but not least, it also provides the graphical representation of the lineage or the path a flow file took within the data flow. This allows you to exactly determine the entire data flow journey made by a flow file.